Number 7. It says triangle CDA. So I like to know, what are we talking about? C, D, and A is the image of triangle ABCE. Okay, sorry, ABC. So we're talking about these two triangles. And it says after a 180 rotation around the midpoint of segment AC. So we rotated it right here. Okay, triangle ECB is the image of triangle ABC after a 180 rotation around midpoint between BC, right here. So then we rotated it over here. Okay, because it is a rotation that we are able to move, right, from here to here and here to here. We know these triangles are what? If they used a rigid transformation to get from one to the other without changing their shape, they are congruent. Okay? We also know when we have rotations of 180, okay, if we have a straight line, it's going to stay at that angle. It's never going to change its angle. Therefore, when I rotate it, okay, over here, that means this also is a straight line, and it's never going to change its angle. These two lines are equidistant from where? The point that we turned them at. Okay? Because that is true, that means that these are parallel lines. Something about that should be written here. You don't just say they're parallel lines. No, tell me why. You have to talk about the transformation. Talk about the rotation. You have stuff in your notes about that. Okay? How did the rotation keep the angles? How do we know that they are parallelograms? Okay? Then you're going to select the pairs of angles that are congruent. Which ones should match? Okay? Do CAB and ACD match? Well, let's see. CAB. You've got to be able to read your angles. So we're talking about this angle and ACD and this angle. Okay? Are they congruent? Think about where you started. Okay? How did you rotate it? Use your trace paper. If those angles line up when you turn it, then they are congruent. If they don't line up, then chances are they aren't congruent. Okay? Continue on. Check. ACD. Where is that? BEC. Where is that? Okay? And the last one. Explain how to use what you know about the sum of angles in a triangle to figure out the sum of angles in a quadrilateral. ABED. Okay, well, what is the sum of angles in a triangle? That's in your notes. They should always add up to 180 degrees. Okay, now you've got 3 of them. Okay, and we're talking about this whole quadrilateral. This whole thing. How many degrees are all 4 angles adding up to? Okay, now you're probably going to be like, oh, easy. 180 times 3. 540. That's not right. Okay? Because you are sharing angles, right? This is not a perfect angle. This is not a perfect angle. These angles we're not even using. Okay? So you need to be mindful about that. Okay? I want you to think about, okay, if you know this angle, if you know this angle, if you know these angles, if you know these angles, you should be able to fill them in on your picture. And also know you subtract these ones out, right? So you should have 540 minus these 3 angles because they're not going to count. I also want you to think about what kind of angle is that. Those 3 angles create what kind of angle? What kind of line? How much is that equivalent to? What do you know to be true about a straight line? Okay? Use all of that to help you try to figure out. You can also think about, well, if I just had that shape in general to kind of check my answers, we know how to find the sum of the angles in any shape, right? You start with a corner and go to every other corner. So how many triangles do I have? I only have 2. So I've got 1 here, 1 here. Think about, this is 180, this is 180. How much do they sum up to? But you need to talk about this shape. You can use this to check your answer, but this is the shape we're talking about in reference to C. If you've got questions, come see Miss G. I'll help you out.